Fall 2010, question number 10. We have 4 series and we're asked basically which of these converge. So, Roman numeral 1, that e to the n forces it to diverge. Think of this as a geometric series with r equal to e. Because e is bigger than 1, it diverges. The series is the sum. The limit on those terms are definitely not 0. Number 2, 1 over n to the e. Hopefully you recognize that as a p series with p equals e. When you get p equals e, which is greater than 1, the p series will converge. So 2 converges. Any answer that doesn't have 2 converging is a bad answer. Only 1 and 4, only 1 and 3, only 3 and 4. We already know that 1 diverges. Anything mentioning 1 is bad. We know that all 4 of them don't converge. And we know that there are some that do converge. So it's a question of what's going on with 3 and 4. Let's just focus in on 4. Whenever you get a series, you should first just look at the terms quickly and look at the limit. Right, that limit is 1. It's not 0. It diverges by the test for divergence. Roman numeral 4. So we have divergence, convergence, divergence. The answer then must be that 3 converges by our choices. Let's show why 3 converges. Unfortunately, it requires a difficult. We saw it in class. Check the video for class. But dealing with n factorial squared and 2n factorial is difficult with the ratio test. But let's give it a shot. N plus 1 factorial squared 2n plus 2 factorial, the limit as n goes to infinity. N factorial squared 2n factorial. And what happens is that we get take off 2n plus 2, 2n plus 1, and then be left with 2n factorial. This is going to be n factorial n plus 1 times n factorial quantity squared. And that's like taking n plus 1 and squaring and taking n factorial and squaring. And so we cancel. What's left over is n plus 1 squared in the numerator, 2n plus 2, 2n plus 1 in the denominator. Hopefully you can see that limit goes to infinity. Goes to 1/4, which is less than 1, so it converges by the ratio test. So 2 and 3 converge only.